So we've got 2 more units left for 6th grade math. This one, cluster 11, is volume. Last year in 5th grade, you did volume of rectangular prisms. This year for 6th grade, you are doing volume of rectangular prisms. You will notice I said the exact same thing, right? The difference is what you have to do with them this year is we have to find the volume where they have fractions on the sides, okay? It's not that big a deal. Most of it's on the calculator active. So this is primarily something you'd have a calculator for. Could you have it on the inactive? Yes, but primarily active. So first off, they start with volume. Volume is the amount of space a 3D object occupies. I also put it usually as volume is what it takes to fill an object. Area is measured in squares, like square units you'll see for area. You'll also see for area, it'll be like, if it's square inches, it'll have a 2 for an exponent. For volume, volume is measured in unit cubes. So if you see cubic something, if it says cubic, that means it's talking about the volume. So the exponent on these labels would be a 3. And one of the ways to remember that always, squares are 2-dimensional shapes. They're 2D. So you got a little 2. Volume is for 3D shapes. You got a little 3, okay? Then when it's packed with cubes, because sometimes you'll see the ones with a bunch of cubes. We'll look at those in a second. You gotta remember, not all of the cubes are visible. I don't have the pictures of those next 2 up on the board, but you can see on your paper, the one on the left, you can see every one of the cubes, right? You might not be able to see like all the sides of them, but you can see at least a part of all of them. The one on the right, there's some of them that are kind of hidden, right? They're still there though, aren't they? So the way this works, when you got the cubes, you can count them out. So like our height, we got 1, 2, 3, 4. Width, 1, 2. Length, 1, 2, 3, 4, 5. Anyone remember from 5th grade how to get the volume there? Multiply. We do 4 times 2 times 8. Length times width times height. We get 40. Does it really matter which one's length, which one's width, and which one's height? For these problems, it does not, okay? If you take a box, we usually think length is like going side to side, width is how far back it goes, height's how far up and down it goes. But if I take that same box, like this one, and I would spin it on its side, well then it's different which one's which, right? Yeah. So that's what I'm saying, it doesn't matter, because you can change order on multiplication. Y'all try 2 and 3 there. For 2 and 3, just give me the total cubes. Gray, what you got for 2? 27 is correct. Number 2, it's a little misshapen up here, but it's a cube of cubes. So all the sides are the same. Number 3, Alexandra. 6 is correct. That one you can actually see all of them. Height would be 2, width 1, length 3. 2 times 1 times 3 still gives you 6. Okay? Easy enough, right? Most of the ones you see aren't going to look like those though. We will do some stuff with cubes inside the shapes. We'll get to those in a few minutes. All right, so like y'all said, volume is multiplying length times width times height. What you also have for a rectangular prism, and it won't look like a rectangle because I'm trying to draw like a 3D shape, but not exactly perfect. The base, think about if I have a box. The base of the box is the bottom of it. When you have a 3D shape and it talks about the base of a 3D shape, that's what it's talking about, like the surface that it's sitting on. For a rectangular prism, that's a rectangle. It could be a square also, but for y'all, it's a square or a rectangle. So the other way you can look at it is by doing base times height to find the volume. You just have to get the area of the whole base. And that works for any 3D shape. If I had like a triangular prism, that's a very bad drawing, but we at least kind of get the idea. I would get the area of the triangle and multiply by the height. Next year for 7th grade, you have to do cylinders. Their base is a circle. Again, not the greatest of drawings, but you would get the area of a circle and multiply by the height. That makes sense? So that's what it means by base times height. Finding the area of the base and multiplying by the height. To me, and from what I see usually with the 6th grade math stuff, that one's going to be the easiest one to use. Same as you did last year, length times width times height. Occasionally though, they'll tell you like a rectangular prism has a base with an area of whatever, and then you just have to multiply that number by the height. So it gives you an area. That's usually where you use the base and the height. We'll get some of those next week. All right, so our formula. We got volume equals length times width times height. You can do this basically as like substitution type problems. You know, our volume still equals, let's say the length is 9, width is 6, height is 4. Then for the volume, you multiply those out. 9 times 6 times 4. If I'm remembering correctly, that was 216. Okay? Everybody seeing how that works? Easy enough, right? It's multiplying 3 numbers together. You don't have to do any division. You don't have to do anything else with it. It's multiplying the 3 of them together. We'll get to some problems in a minute where you have to do some more, but all right, flip that sheet over. On that sheet, it has a couple with some decimals. For the 6th grade math, you specifically have to do it with fractions. Decimals and fractions are pretty similar. So you would still go ahead and multiply these 3 numbers together. So with a calculator, it doesn't make a huge difference one way or the other. You should be able to do it. So we've got length times width times height. So 6 times 9 times 4.5. In this case, that gives us 243. Okay? So see what I'm saying? With a calculator, decimals, fractions, it shouldn't make a huge difference. Number 2 has a decimal. 4 on your sheet have fractions. Go ahead and find the volumes on those. Who's got an answer for number 2? Sydney? Mm-hmm. 116.6. There's a decent chance you're going to have decimals for your answer, okay? Just like if you have fractions, there's a chance you're going to have fractions for an answer also. Jeremiah, you got number 3? 468 is correct. And number 4, Ford?
96.
96 is correct. The big thing with doing these, because at least one of them is going to have a fraction, okay? At least one. Is anybody not sure how to put a mixed number into the calculator? What you do is you put the whole number first. So in this case, I would put the 4. Then you press the unit button on your calculator. It's the top left white button. And what that gives you is a line. Numerator. Then you got to hit the down arrow, denominator. And this part's important. You got to hit the right arrow, and then you got your mixed number. Okay? Everybody's good with that then? All right, this isn't on your sheet. Go ahead and find the volume for this one. As I said with the decimals, if you got fractions in a problem, there's a good chance your answer ends up with fractions. This one ends up with some fractions to it. All right, Sarah, what you got? .24 3/8 is correct. Look, there's nothing special to it. It's just multiply the 3 numbers together. So 3 1/4 times 1 1/2 times 5. Okay? That puts you at least in the ballpark. So that can usually eliminate some of the answers. If you like round them down like I just did, you know the answer is going to be higher than 15. So that can always give you a decent guessing or starting point. All right, so the other thing you might have to do is find a missing dimension. What that means is like you're looking for the length, width, or height. So it gives you the volume. So what you do is you start with the volume and you work backwards. In math, when we work backwards, we do the opposite. So what's the opposite of multiplication? Division. So go ahead and give that one a try. Gray, what you got? And I'll take it. When you have fractions in the problem, we should have fractions as an answer though, okay? Or that's what the answer choices are going to look like. It'll be 4 1/8. If you ever do happen to get a decimal, because if I'm putting this in the calculator, putting that as 2.5 is a little bit quicker. Just hit the FD button, which is 2 up from the 8, okay? And that'll change it to a fraction. Any questions on that? And when you enter that in, you can literally put it just like I wrote. 165 divided by 2 1/2 divided by 16 and hit enter. You can do it all at once on the calculator. Order doesn't matter other than you have to start with the volume. The volume has to go first, okay? Any questions on that? Relatively easy then. If they give you the volume, you just gotta remember you're doing opposite, so you divide. All right, so here's how it can get a little tricky. Who thinks they can tell me what three numbers I need to multiply here? Kyle? Nope. Sydney? 5. Jeremiah? Nope. Nope. Three times 2 times 1.5. Who's not sure where 1.5 comes from? All right, so here's what the problem is with this, okay? Here's why this gets a little tricky. Those ain't the same, are they? For the math to work correctly, we need those to be the same. So that means the easy one is to change the inches into feet. Technically, you could change all of the feet into inches as well, but that gives you huge numbers then. So how many inches are in 1 foot? 12. So if you divide 18 by 12, that gives you 1.5. Okay? Everybody follow on that? That is about the only way, like, a regular looking problem can be a little bit tricky. So always kind of keep an eye out on those labels, okay? All right, so here's the other thing we can have, or one of the other things. We have to see how many cubes that have side lengths of 1/2 can fit into the rectangular prism on the left. So here's how this works. We have two shapes. We have a big box and we have a tiny cube. Okay, those are our two shapes. So the first thing we want to do is find the volume of the big box. So we go 4 times 1.5 times 3.5. So, whoops. So we got 4 times 1.5 times 3.5. That's 21. Everybody good on that? Now, where it gets a little trickier and the part people forget about, we need the volume of our tiny cube. So what's the length on our tiny cube? 1/2. What's the width on our tiny cube? 1/2. What's the height on our tiny cube? 1/2. So for the tiny cube, we got 1/2 times 1/2 times 1/2. That gives us 1/8. Everybody clear on that? Everybody see how that goes? Now, we're trying to figure out how many tiny cubes fit into the big cube or big box. What type of math do we do? Division. So if we do 21 divided by 1/8, 21 divided by 1/8, that is giving us 168. Okay? Any questions on how that one looks or works? You got a big box, you got a tiny cube. We're seeing how many times it goes into it. So you got to find the volume twice on those. This one doesn't have a picture. Y'all give it a try though. Oh, also with these where they ask how many cubes, you should get a whole number. So that helps a little bit. Gray, what you got? Nope. Ford?
30,888.
Yeah. So there's our big volume. That's the big box. 8 1/4 times 9 times 6.5. For the tiny cube, I think you forgot about the volume for the tiny cube. We got to do 1/4 times 1/4 times 1/4. That is 1/64. Then we're dividing. So we got 482 and 5/8 divided by 160, not 16th. Oops. Divided by 1/64. Okay? When we do that, what do we say? 30,888, right?
Yep, 30,000.
Sometimes the numbers get pretty big pretty quick, especially if you have some larger numbers in it. Like dividing by 1/64 is basically the same as multiplying by 64, so that gets it pretty big. Any questions on that? It's not horrible, but it's got a little extra that gets a little tricky. The part where people mess up is usually that part right there. They forget to get the volume and just divide by the 1/4, okay? So careful with that. All right, so other types of problems we can see. This time, it gives you the number of cubes. So when it gives you the number of cubes, we're doing the opposite. So we got to multiply. Yeah, we're going backwards. So we take the number of cubes. Now where it gets, again, a little tricky, if it gives you the cube's edge length, we got to do 1/2 times 1/2 times 1/2. So we're going to be multiplying by 1/8. What was it? 1/4. Okay? Everybody see the difference there? If it asks how many cubes, that's where you're dividing by the volume of the cube. If it asks for the volume, you're multiplying by the volume of the cube. Okay? But either way, you got to find that volume of that little cube. Okay? All right, y'all try that one. David, what you got? 108 is correct. All right, so we start with the number of cubes they gave us, which was 256. We're going to multiply by the volume of the tiny cube. The volume of the tiny cube is 27/64, so that's going to give us 108. You get the 27/64 by doing 3/4 times 3/4 times. Okay? Any questions on that? height, right? So we're going to be multiplying the two numbers together. If it has a square base, what do you know about squares? All the sides are equal, right? So that means our length and our width are both going to be 6.5. So we got 6.5 times 6.5 times 11. So odds are good if it ends up talking about a square, especially a square base, you're going to reuse one of the numbers twice. The length and the width. On that volume, 3D shape, 3 numbers multiplied.